Show me what is on the screen. Okay, cool. So now there is recording started. Awesome. Hi everyone. Welcome to the new session in this new year. So in the new year, we are trying to practice the string problems. We completed arrays, around 14 problems in arrays. We shared all the recordings on and code links of these problems. We practiced single dimensional arrays and 2D matrix arrays. Couple of problems in matrix. Now we are going to start the string problems, around 9 or 10 problems in strings. So we are going to start with the problem called palindrome. So how can we find whether a given string is palindrome or not? So palindrome is something where even if you read from the last character, it should give the same word, right? Here is one example. Um, and it's another small example, and here is another one, race, which is not a palindrome. So if it is palindrome, we need to return true. If not a palindrome, return false. This is the algorithm we are discussing. Sammy, thank you for good algorithm. You shared one of the logic to solve this algorithm. You said you're going to create a um, separate string, right? This is a given string, and from the given string, you are going to create another string, and then you compare each letter from starting from first character here and also starting first character in the second string. Correct?
Yeah,
Yeah, that's one way of doing it. So that's a good. It's not a problem. Now let's put another condition to it. Let's say this is a very big, right? The given string is really big, and we don't want to. But let, let me put this way. You can still use this idea, but how you create the second string? So this is the race is the given string. You said you are going to create another string with the reverse of the characters, right? So how to, how are we going to create that?
yeah, but we used to do in numbers in an array numbers. Means we used to practice in numbers. We haven't done much in strings, so I have not. I don't have that much idea.
I
But in
see.
numbers, we used to just copy the string and we reverse it using the reverse array logic, and then compare it. If it is true, true. If it is false, then false.
Okay, numbers means a string of numbers or a string with numbers.
No, no string, like just an array number.
No,
If it
array
is a
of
number,
numbers.
is there
Yes,
like
I
one
see.
zero zero one lakh, like that kind of things.
Yes,
We used to
yes,
practice.
like this, right? So here is an
Palindrome,
array.
Armstrong, like that.
Yeah, this is an array, and you're going to convert this array into different array like this. So first of all, in order to convert that into a different array, you need to traverse the entire array, right? Let's say this is the input array A1, right? So now you need to create A2. This is array 2. Okay. In order to create array 2, what you're going to do? You're going to start from the ending, right? And take that element and put it here, right? 4 will be here, and then you decrease index and then put it here, and you decrease one more index and put it here. So that way you're going to create array 2, right? Then you can compare A1 and A2, right? If A1 of 0 equal to a1 of a2 of 0, something like that, right? If both are equal, you go further and then you compare this next element, right? So a0, a1 of 0, a2 of 0, a1 of 1, a2 of 1, something like that, right? So when both did not match, immediately you will say it's not a palindrome, right? Is that the logic you're saying?
Yeah, kind of.
Very good.
No, kind of. It's exactly what we
Yes.
used to
So
do.
this is the similar one. You can also think the string as an array of characters. Right? What is string? String is simply array of characters. You can definitely, let's say the string, this is str1 equal to str1 equal to the string tag. So now str1 of 0, what is the value? str1 of 0 means what character is that? Any idea?
That's T.
T. Yeah. str2, str0. Let's say of str of 1 is
A.
A. Simply that's how it is. Just an array of characters. You can think TAT as basically array of characters like this. T, right? A, T. So that's how it is. You no need to convert that into a separate string or anything. You can literally take each character by using the index. That's the beauty of strings. Strings can be manipulated just like normal arrays. Okay, so that's in every language. That's how it is. So now what you're saying is you want to create a separate array and then compare each element. That you can still do it. That's a good algorithm. But here is the problem, right? We are using extra memory. Let's say if I am giving you this is just 9 letters or 10. If I am giving you 1,000 letters, a string with 1,000 letters, you are going to take one more string with another 1,000 letters. You are going to put that in a reverse order, and then you're comparing. That's still fine, but how can we do it without even initializing another string?
In constant space.
It's a constant space. Yeah, yeah, you can think of that. Even taking another string is also constant space. I would say, oh no, no, it's not constant space. Yeah, it will increase based on the input. If I say 100 characters, you are going to take another string of 100 characters. If I'm giving you 1,000 characters, you are going to take another 1,000 characters. So in that case, the space complexity sc equal to order of n is the number of characters in the input, right?
Yeah,
N
it will
equal
become
to
n square.
number of characters in the given input, right? So we want to reduce that. How can we do in the space complexity of one, of order of one? That means it doesn't matter. Uh, it doesn't matter you give 100 characters with 100 characters, a string with 100 characters or string with 1,000 characters. I don't take an extra memory. I will just take order of one. I will take some, let's say 4 bytes. That's it. It doesn't matter how whatever the input is. Always take 4 bytes. Just telling an example. So it's a constant space. It never increases based on the input. How can we do that? That's the main that's what we are trying to achieve. Any ideas, Tarun or Arshad? Are you guys following?
Yeah, Suresh, we can loop to the string till the middle of the string. We can loop
Mm-hmm.
for every character. We can check it with the. We can
Kind
loop
of.
the string.
Very good. Loop the string means
We
okay
can
from.
run a for loop
Mm-hmm.
throughout the string
Mm-hmm.
from starting till the middle. Like if it is an even string, will then there will be a one case. If it is an odd string, then we don't need to compare that middle one.
Yes.
So we'll compare the first character with the last character, kind of that. So that's the solution I'm
We
thinking
can
of.
also do like we can put I is equals to 1 and j is equals to string dot length minus 0, string dot length minus 1, and like that we can compare. If
Mm-hmm.
they are equal, then we will go. If they are not equal, then we can break the loop and we can say it is false.
So I understood the Arshad the idea of comparing half of the first string with the half of the second string. And so what's your idea, Tarun or Sammy? You said something different. Is it the same idea?
What I
Mine is
said
similar to Harshad.
what I
Okay.
say is like we can compare this since it's a character string is a character string.
Yeah.
So what we can do is like we can compare this like I is equal to 0 for initial index and with the last index,
Yes.
final index. We
Yes.
compare the but then we can come near closer to them, and the moment they are not equal, we can say it is false. If they are equal, then we can say that it is
It's a parallel.
equal.
Yeah.
It's true.
Yeah, if you reach at the middle by comparing without any problems, then it's a palindrome. That's exactly what Arshad was saying, I think, right, Arshad? That's what you also said, taking first half and second half and comparing first one here and the last one here, right?
Yes, Suresh.
Yeah, very good. That's the actual algorithm we are going to discuss. So it's very simple. Basically, here I would say, it taking like what you said, Arshad, is right. Like if it is a string with odd number of elements, you don't need to compare the middle element. Just take the first half here and take the second half here, and then compare first element here and the last element here. And if they are equal, then decrease this one and increase this index and decrease this index, and then compare A and then L and L, right? So do you think it's a for loop or while loop? I was thinking while loop is enough. For loop is always you specify end index, right? You can still do for loop, but it's kind of, you need two indexes. You need to take something on the first half and an index on the last half, right? So two indexes we need. And when do you stop? Whenever they reach the middle, isn't it?
Yes,
Yes.
Suresh.
So that's what it is. So you can take simply two indexes. You can still do it with for loop. I'm not saying for loop is a bad. You can still do it with for loop, but simple to understand and easy to follow is just having two indexes with while loop. Yeah, awesome. I saw someone there, Datta. Hi, Datta. Welcome to the class. We are just started discussing one of the problem. Um, Datta, is it first time to the session or you already came before? Just want to.
Yeah, I already joined Dattatreya here.
Hey, Dattatreya. Oh, yeah, yeah. Now I remember. Okay. Welcome to the sessions and Happy New Year, first of all.
किसी की बेटी को इतना मजबूर Yeah, wish you the same, Anya.
Thank you. Thank you. Are you also from Hyderabad or somewhere? Where are you?
I'm from Ponnur in Guntur.
Ponnur in Guntur. Okay, okay. Awesome. So, is that also your friend of Tarun or who introduced? I forgot how you came to.
Tarun.
Very good. Tarun, all of your batch is here. You are the leader. Very good. Very good. Very good. So, Dattatreya, we just started
All are
discussing.
from iFocus, Suresh.
Very good. Very good. All are from iFocus. Even I am from iFocus. Very good. Yeah, bring more people. We will focus on this very important aspect of our careers, like the coding sessions. So Dattatreya, we completed last 3 months. We completed the around 14 problems in arrays, two-dimensional arrays, single-dimensional arrays. Now we are discussing the string problems, around 9 to 10 problems on strings. We started the first one. So we are discussing string palindrome problem. Are you part of the Discord? Are you in one of these groups?
Yeah, I was there in the Discord.
Oh, here is the one, that three. Yeah, yeah, I saw that. Very good. So you already got the information, right? Cool. So nice.
Yeah,
Very good. So
yeah, sir, but I didn't go on those.
didn't got.
I will definitely go on through those things.
No problem. Yeah, no problem. Yeah, around I post around a couple of hours before on Saturday or Sunday or Friday or Saturday, like what are the questions we are going to discuss. So it will give a little bit of idea. If you already know everything, you can just skip the entire session. You can watch a video or movie, whatever. But if you have some time, you can go and do some research before the class. You will get some idea what is palindrome and how to find these problems. That will give you clear understanding. You can follow the conversation much quicker. So that's the reason I'm sharing the problems that we are going to discuss ahead of time. So it's up to you. Anyone can read about it or just know about it, or if not possible, you can directly come to the class. We will discuss anyway. So now we are discussing palindrome. So we discussed about one idea of checking the palindrome is converting that string of characters into another array. A1 becomes A2, and then compare each character, first character here, second character here, and whenever they did not match, then we say it's not a palindrome. So reversing the entire string and putting in a separate variable and comparing the characters, that's one way of doing it. Only problem with that, that is good idea, but only problem with that is space complexity. The space complexity is increases, right? We need to take n number of characters in the given, so order of n. So when the n increases, when the given string increases, you need to take more space. If I'm giving you a string with 1,000 characters, you need to take one more string with another 1,000 characters, and you are reversing the entire string into another string and then comparing. So that's where the space complexities increases. Now we are trying to solve in order of one space. That means without using any extra string or extra array. So we just discussed about it. So the idea is take the entire string into half and half, basically take the first half and second half and compare each element from the beginning here and last here. So taking two indexes, compare m and m, both are equal. Now compare a here and a here, both are equal. Let's go further. So l here and l here, until you either you meet the middle or you bail out of no comparison, like both are different. Let's say I'm giving something like this. It's almost like Malayalam, but little bit of change. Let's say L is K here. Malayakam. Is it true or false?
False.
False,
It
right?
will not. It is not equal. It's not a palindrome.
Yeah.
Yes.
So we'll start with M and M. M here are equal. Now we will increase one index here and we will decrease another index here. A and E are equal. Now we will increase one more index L and K. That's where you break the loop. Okay. We found a different characters on each side. We will simply no need to compare. Let's say the string has 1,000 characters and even just a third character itself is did not match. In the middle you will have another 1,000 characters or 500 to 800 characters between this k, this l and k. It doesn't matter, you no need to go to each and every character. So it's your, you just found with three loops, only three comparisons, your algorithm will say this is not a palindrome. It's very efficient. We are not copying the entire string into another string, and we are not comparing every character, right? We will compare only to the point where you find the difference. That's it. We'll stop there. So that's why that's a very good algorithm that will solve in order of one space, because you don't, it doesn't matter whatever the input. I'm not taking another separate I'm not taking another separate string, right? That's why order of one space. What about time complexity? So let's discuss the time complexity of the previous algorithm and the new algorithm. The previous algorithm is converting a given string into a given array. A string is just a character of array of characters, right? So if I'm giving TAT, that's a TAT. So three elements. Basically, a string is array of characters. So now think of that. This is a string 1 2 3 4 I given, and you converted it to 4 3 2 1, right? So that's one aspect of doing it. First, before even comparing, you need to and scan the entire elements and create the second string in a reverse order. That's one part of it. It will take some time. And then second part is comparing each element. First element here, first element here, second element here, second element here. So now can anyone tell what is the time complexity of that first algorithm? Anyone?
N is square because we are looping it two times.
Okay, n square, I would say n square, something like this. Okay, that's one answer. Anybody want to contradict or support? Anybody like who says it is n square? Sammy says n square. Arshad or Tarun, is that n square? Arshad, go ahead. Did you follow my question?
which we discussed, it is order of
So we discussed about the first algorithm where you converting the entire string into reverse string and then comparing first character here, and then
Hmm.
like that. So what is the time complexity of that particular algorithm? Basically,
Even then it is n only, right?
you're
Even then
thinking.
it is order of n only, because that
Mhm.
is different and this is different. Two parallel n plus n, even then it is n only.
N plus n, I know it is order of n. You're saying order of n, but I would say in a precise manner. I know it is order of n, but in a precise manner, it is order of 2n. Of course, order of 2n is n.
2n. Yeah,
2n. It's
2n.
not. It's not
But
n squared.
generally we consider O of n, right?
Yeah, order of n. Definitely, it is order
Yeah.
of n. But it's not order of n square for sure. Can you explain why? Why it is not order of n square?
Because it is not nested, it is like, parallel. One
Exactly.
loop is getting completed, another loop is getting. For each iteration, we are not doing. I mean, if it is a nested loop, then it will be n square, right?
Yes, yes,
That's it.
that's the part we need to understand, Sammy. So why it is not n square is when it is n square, and n square means what is the what how many times we are looping? It's just a four elements, right? How many elements? We have four elements, and four into four, 16 times. Are we doing 16 times? If it is 16 times, then it is n square. That means take 1, 2, 3, 4,
Yeah,
and
you are not
create
doing.
4, 3, 2, 1. How long it takes just looping 1, 2, 3, 4, right? That just looping from one first character to and last character, which is n times. You're taking each element one time, so that is you need four times. You will take four times, and you create another four elements, right? That is order of n. Now, once that is done, right? What you do next one is comparing, right? You take first element here and compare the first element, you take second element here and compare with second element. How far you do? Four times. So four times and four times, which is
Yeah, definitely.
two into four times, right? That's why it is called
Yeah,
2n.
yeah, exactly. That's 2n.
2n, it's not n square. N square is
I got it.
when you do 16 times. That means take 1 here and compare with 4, 3, 2, 1. Take 2 here and compare with 4, 3, 2, 1. Take 3 here and compare with. That's how it is. 4 into 4 times. Then it is 16 times. That then it is nested.
Yeah, yeah,
Nested means take one character or one letter from array, and then comparing with that every element in the second array, and take the next one and comparing with every element in the second array. That's what it's times, right? It's basically you take 4 into 4. That's where it is n square. So now you're not doing it, right? Now you understand clearly why it is
yeah,
2n not n square?
yeah. I understand. Understood.
That's very good. So the very important aspect to understand what is 2n, what is n square, when we say n square, when we say 2n. So very interesting thing. So let's strike out this one. It's not, there is somewhere strike off here. It's not n square. It is order of n, because order of 2n. Order of 2n is also order of n. We don't consider that as a precise thing. We simply say order of n. So now coming to the time complexity of the second solution, where we compare first character and last character, and then next character and next character. What is that time complexity? We know space complexity is order of 1. We reduced space complexity from order of n to order of 1, means we are not taking an extra array. But what about the time complexity?
Open.
Often, definitely often. It never be two and also. You don't even you don't create any second array, right? Here in the first algorithm, you are going from beginning to end two times. First time is you are creating the ordinary auxiliary array, or the temporary array, and second time you are comparing. Two times you are navigating from beginning to the end. But in this algorithm, you are navigating on every element only once. At max, what you do is, at max you compare all the elements. Let's say it is an even number of elements. Let's say this one RACE. or something like this. Okay, TAAT. So what about this? So you will compare the entire string, right? So this is the first half. Let's mark the first half with the same color. So here is the first half and here is the second half. So you start with T and you start with this T, and then both are equal. Then this A and this A. So that means every element you touched it. That means every element, how many times you touched? Only once, right? So order of n. Here, of course, it's not even order of n. You don't even touch the middle one, and even the second one, it's not order of n. Of course, the maximum. Whenever we say time complexity, is always the what is that? The worst case. Worst case complexity. Time complexity means worst case. In the worst case, this is the worst case. You touched entire strings. You touched all the strings of the given input. Of course, you just touched only one time. That's why it is order of n. But in this case, it's not even order of n because you bailed out of the loop after third comparisons, right? L and k is not equal, and your algorithm returned the final answer false. So of course, that's less than order of n. You did not even compare the middle elements, right? So but in the worst case, what you do is you compare all the elements one time. That's why it is order of n. So in the first algorithm, it's even little bit of worst thing. The worst case is order of 2n. So the second algorithm is way better. It uses order of one space and order of n time complexity. Space wise also efficient and time wise also very efficient. Are you guys clear on these time complexities? Any questions? If no, I can show the code.
Yes.
Very good, very good. So that's
It's
very,
clear, Suresh.
yeah. See, just we discussed more than half an hour on this very simple algorithm. And if I'm the interviewer, I don't even ask them to code it. This whole discussion itself telling how much you know about this algorithms, how much you know about time complexity. This discussion, these two ideas. First, if the Arshad came up with this idea, if Arshad came up with this idea, Arshad or someone, I don't know, is it Arshad or yeah, if someone came with this idea of creating second array, I don't ask him to code it immediately. I will have this discussion. I will say, oh, very good, Arshad. If I'm the interviewer, I will say, very good, Arshad. That's a good algorithm. Let's talk about complexity before going into the real coding interview. If you're able to figure out this algorithm, then this comparing first and last algorithm, then I will ask for the same thing. Hey, very good idea. You came up with another good solution. Let's talk about complexity. Now, if you're able to answer these questions perfectly, I will be super satisfied. Even if you don't write single line of code, I will be super satisfied with the candidate because he knows the things. He understands the difference between different algorithms, the pros and cons, how to manage the memory, how much it takes to execute an algorithm. These are all the things very matters, right? So writing the code is the last part. If we still have time, I will say, okay, write the code. I will ask to write the code because it's a matter of one or two, just one while loop. It doesn't take 20 minutes or 30 minutes to write this, right? So this is very good algorithm in the interview perspective. It will have a lot of discussion points. It will enable interviewer to explore the the proficiency of the candidate in terms of time complexity, space complexities, how to solve problem in a different approaches, all those things. So finally, I will share the code. It's very, I hope you guys can write the code in fact. So, but for the sake of simplicity, and I will show the code directly. We can actually, if you write the code, that will be more better. But I will share the code. So here is the code. It's in C sharp right now. So here is the given string, and is palindrome is the method. Simple. As we discussed, I just took two integers. It doesn't matter the string has 1,000 elements or 10,000 elements. It doesn't matter. I need only two integers. Let's say two integers take 4 KB. I'm just making up some memory. I don't know how much memory it will take. Integers will have 2 bytes or 4 bytes. I don't know. If it is 4 bytes, each integer, it will be 8 bytes. Just 8 bytes I am taking. Doesn't matter of the size of the input, right? It's a constant space. I am always taking only two integers. So one is setting to 0 and the j set to length -1, which is the last index. And this is the while loop, while I less than j. Simple, right? So that means if I crosses the middle, or j crosses the middle in the backward, then we will stop. When I and j equal, when they both will equal, when they touch at the middle for the odd number of elements. For the even number of elements, what will happen is I will go beyond the middle element. J will go beyond the middle element in the reverse order. That's where we it break the loop. Okay. So simple comparison. If any of these not equal, we simply return false. Otherwise, that means both are equal. So I plus plus, j minus minus. Very simple. I don't think any problem to understand this. Let me know if if you did not understand any of the line, or I can explain again. Is it clear? Give a thumbs up or something so that I know you guys are
It's clear,
following.
Suresh.
Very good.
Can't we write a break after false, because I think since it is false, it should break the loop and it should move out.
Why do you need to move on? You just need to return false, right? You no need to compare any other elements.
Yeah,
Yes,
so don't we have to write break for that?
we can break. If you
Break.
break it, it will come here. Then it will return
Okay.
true. We are returning true when you come here successfully. That means you completed the loop and you never entered into this situation. You never enter into this false situation. That means all the characters from the front are equal to the characters from the back. So when you come
Okay.
here, line number 38, successfully, that means first half is equal to the second half in reverse order, isn't it?
Yeah. Got.
That's why I'm not breaking the loop. I'm simply returning false here. I don't want to come here if something went wrong. If they did not equal, if you want to write that way, you can still do it. But you need to maintain another variable. So something like this. I can write it simply. What you're saying is you want to break the loop. So then I need another variable to maintain whether it is, you completed or not. Okay. Something like, oh shit, I need to open this in a different window. If you
No,
want to change that.
it's okay. I got my
Yeah,
corrections. I got it.
I can still write that logic. But anyway, you got the point, right? We don't want to come
Yeah.
to the
Yeah.
end of the loop if anything goes
Yeah.
wrong. Yeah. Cool. That's the first one. I think it's already like almost 9 or 10:30 for you guys. We can discuss second one, or we can discuss the second problem next week. So
No, let's discuss it.
yeah. So this one we just discussed, right? So this one I can we so there what are the different test cases? I'm giving only positive test case here. It is BA. This is like how many characters? 1 2 3 4 5 6 7 8 9 10. 1 2 3 4 5 6 7 8 9 characters here. And here also 1 2 3 4 5 6 7 8 9. See, both are I gave the odd number of characters. I should put another with even number, right? That's another important test case. So let's discuss about different test cases, right? As we discussed, let's say this k, right? So this is one thing. And another test case would be, you guys need to tell what are the different test cases. This one will be even number, right? T A K A AE something I'm just making up, and EK 80. Okay, this is even number, right? Even number of characters, isn't it? So 1, 2, 3, 4, 5, 6, 7, 8. And here is, this is odd number, odd with false, expecting false here. And here is odd,
Udo.
odd expecting true, right? And here is the first one is it true or false? I don't remember the output. So I can run it and see. Okay, is a palindrome false. First one is this is odd with false. We odd with false. Expect false, isn't it? So odd expecting with false and odd expecting with true, right? Odd number of elements expecting true here. Second one is true, and odd expecting false. This is also odd expecting false, and this is even number of characters and expecting true. This is true, right? Next one, another thing, even false, even number of characters. You guys need to tell all the test cases. So even number of characters expecting, which is expecting true here, right? So false, true,
Yes.
false, true, false, because it is false. Let's say PAKE and X here. I just put. So let's run it and see. Is it matching our expectations? False, true, false, true, false. Yes. Now, can you tell me any other um, test cases?
Udo. Udo.
What is
Empty
O
string.
D D O.
okay? But is it okay? ODDO, ODDO. This is even number, even not event, even number of characters, even number of characters. Expecting true, right? OD.
Yeah.
But how it is different than the other test case? We already have even with true. Yeah, we have the exact same thing. Even number of characters expecting true. There is no difference, right? This one and this one is same. Same test case.
Null, null, sir.
That's right. That's very good test case. Rather than saying empty string, empty zero number of characters. I would say zero number of characters. And what do you expect?
False.
False. But it looks like our
There is
my,
nothing to.
my algorithm zero empty string. It is string. I forgot to write G here. Okay. So I think my algorithm returns true. Let's see. Yeah. See why? Why it is returning true? Because it is an empty and the I equal to 0 and j equal to j becomes minus 1, right? 0 minus 1 becomes minus 1, and then while loop will break it and simply returns true. You guys understood why it returns true? If you are expecting false,
Yes.
if you are expecting false, then what we need to do is we need to change the algorithm little bit. Just a boundary condition. If str dot length,
String is empty.
yep, str is empty. Don't use is empty thing. Those are the latest updated all functions, the inbuilt functions. Don't use inbuilt functions other than length. Length you can still use it because otherwise you can't even do this. So length is okay, but don't use uh, what is that, the empty is empty
No
or
stress. I was like, normally telling.
yeah, yeah, yeah,
It's
sure, sure.
not. I'm not telling to use that line. Yeah, is empty function.
Yeah, just length equal to zero. I know you are telling just telling the logic, but always try to use the not don't use the inbuilt functions. So if the length is equal to empty, if you are returning false, return false because it's up to the definition. I would say it's still a palindrome, but if you think it's false, that's fine. You can simply return false. Any other test cases you guys can think of?
And I think for single word, single character like A or individual
Mm,
B, C,
very
it
good,
is it
very
written
good,
true.
very good.
Odd and true.
This is very
For
important.
individual, odd and true.
Odd and true. We have that right. Odd number of characters expecting true, which is
Yes, sir.
odd with false. Odd
Single
expecting.
character in the sense odd and true only, no, sir.
Oh, it will. Yeah, single character means odd and true, but it's a different case because it depends how you write the logic. So better to test that scenario, right? I know we tested something like this. It's equal to odd number of characters and expecting true. I agree with you, but it is always better to test that single case to make sure nothing was broken, right? So why it is taking this much time? Let me stop it. Compiling problem. Something went wrong. Is still it should be false. Okay, it should be very quick. I don't know why. I hope it is saved. Yes, it is saved. Let me reload this page. So that's one good case. Single character string is so when we are doing interviews, it's always very important to write the test cases. In one of my interviews, I still remember around 7 6 7 years ago, I wrote the algorithm. He keep on asking me to write test cases for more than 5 minutes or 10 minutes. I'm saying like write few more test cases. There are few more test cases. Write few more test cases. I was so frustrated. Like in the whiteboard in Microsoft, he's asking me to write so many test cases. He's saying that's it. I said, yeah, that's it. I said. He says, hey, there will be a few more test cases. Think, and write. So that's why I'm saying it is very important when we write a simple logic, we need to figure out what are the different test cases we have to test it. Okay. So I'm going.
And in development also, there will be chance of getting all these test cases, right?
Yeah, definitely. When we are really doing any project development, right? So we always want to write the unit test cases and make sure you cover your code with all these test cases. Yeah, cool. So we expected a false, and we got the false. Okay. Now, as he suggested, is it Sammy? You suggested one more test case with single character, which is important. I totally agree because that is a special test, special case. Let's say Z. So single, C char, yeah, okay, character, single character string. So one number of characters expecting. What are we expecting? Are we true or false?
True.
It is true. You can read the single character from the back or front. It doesn't matter. So let's see whether our algorithm
Yeah.
returns true or false. Okay, you got the true. Now I would say one more interesting case. This is empty string, right? How about white space? You guys know what is white space? White space means it looks like
Yes.
empty, but it's not empty. Like this. What you get if I just put one white space? True or false?
True.
It
It
will
will give true only because it is.
it's just like one
Uh,
character, right?
yeah, exactly. It will compare it and it will return true.
So because it's just like one character, it doesn't matter what you have in that character. So whether it is white space or any other special character, Y P R U E N,
Uh,
right?
did white space also considered as a character?
Yeah, everything is character, right? Everything, even if you put a special character there, it will be a character. Why not?
Okay.
Right? Oh, this is empty white space. This is string, right? String can contain any characters. You can also put numbers here. Doesn't matter. You can put any. Let's say these are also characters, right? So this is white space string. White space string returns true. Now think about two white spaces. That will also true, right? You can write a number of things. So this is like two white spaces will return true. But what about three white spaces? Should return false, right? No, no, not three. Three also returns true. It doesn't matter how many white spaces. It's always so true. All these are true. See, true, true, true. Everything is true. So now you're saying like special characters. We can try that one also. Why not? Just string. String can contain anything. So special character string. So here is a special characters, and let's say, do you think this is a palindrome? Is it a palindrome?
No.
No.
Yes. Let's see. We are expecting false. Yeah, we got false.
Case sensitive also. If we put
Yeah, that's also good thing. Space case sensitive. See, if you are discussing, you can write 100, like test cases. So before,
It will obviously be case sensitive. I mean, it will obviously false na Suresh, because the ASCII code is different for those strings.
exactly.
For small a it is different, for
yes,
capital A it is different.
Yeah.
When
So
it is
that,
comparing it, obviously, I mean,
yeah, right.
I told the reason why it is false.
That's good reason. Yeah. So this is true because they are special characters, but I put it in a specific order. No, I think it's not. It's not. It should be like this. Let's say, let's say something like this. This is true, right? The special characters, but in a particular order, it should return true. And you said it's a case sensitive thing, so that is the next one. So a x x a. Are we expecting true or false for this? False, right?
It will give false only.
Okay, see, this is false and this is true. See, percentage, dollar sign, percentage, which is exactly in a palindrome, which is true, and this is false. A because capital A is different than the small a, so that's right. So yeah, those are the things. Any other test cases that you can think of? You can put in a normal way as well and make sure it returns true. Let's say here, now we expect true, right? Okay, any other test cases? Yeah, we got true here. Cool. See how many test cases we wrote: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Around 14 test cases. Initially I started with just two test cases I added, but now we have 14 different ways. There could be more. We don't know, right? So there could be one with the maximum number of strings on a string variable. I don't know how many characters a string contains. It depends on the language too. C sharp and Java will have different lengths. Example, I'm just putting some example. Let's say Python. Every language has its own max length. So we should also test with a string with max length, a string with 1,000 characters, string with 10,000 characters. Make sure your algorithm works well. That could be another test case, but I don't want to write that anyway. Got it, right? It's a very simple algorithm, but you can have 45 minutes of discussion on this simple while loop algorithm. So I don't always look at how long the algorithm is, how many lines of code. It doesn't matter. Even just one line even like couple of 3 4 lines we can discuss for hours, right? It's all depends on the discussion, how the discussion went between interviewer and candidate. That is very important than the number of lines of code you wrote. Okay. Good. It's already 9:15. I will just discuss this algorithm and maybe like just explain the algorithm. You can think of it. And since you guys have this, someone I think Tarun, you have this book, right? You can look at this algorithm on page number 192. You can think, and if you did not understand, we can discuss next week. You can also share the solution with others. But yeah,
So
yeah.
those things were there in lead code like that. I had it got outdated. The book was outdated, and the problems were there in lead code like that. I had
Sure, sure. You mean like these two
each.
these two algorithms as unique characters and the check permutation? Are those things you're talking? Which one you
I don't know exactly, sir. I have listened to the YouTube video.
okay?
There in the he discussed that all of these things, the book which you suggested, those things were there in lead code like that. I heard.
Yeah, yeah, yeah. Most of the problems already in lead code, and do you think that book is not used anymore, or outdated in the sense like what is meant by that?
I think
Uh,
digital form it may be available in lead code.
Actually, like many YouTubers say that no, you don't need books because all the things that you need in a book, which is there in the cracking coding interviews, is there in the lead code. You can have solutions, you can have
Definitely,
suggestions all there.
I agree
So you
with that.
don't need a book. So he's saying like that.
Yeah, people will say that. Just think about, even why do you want to go to college? We don't need to go to college. Everything is out there internet. Right now I can sit at my desk, I can finish my PhD. I no need to go to college also, right? Because everything is in internet right now. It's not a thing that it's not there in the internet, but the having a book is really, connects. It matches your what you do in the college days, right? So if you have a book and pen
Yes.
and paper,
Yeah,
that really 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 interest you to do more and practice. Digital forms is always a benefit, and also there is a problem with that, right? So
yeah,
you don't have start and end point. You don't know where to start, you don't know when to end. You can store the links. Again, that's another thing, you need to go and search for that. If you have a book, at least one book, I'm not asking you to buy 10 books. If not CTCI, if it is outdated, buy another good book which is popular nowadays. This is the book which is popular 5 years ago when I was practicing these questions. I hope it is still good. There will be another good books than this. I don't know. I'm asking, like, I'm suggesting to have one book at least, so that you will have that kind of connection with that concepts. You can refer anytime. It's kind of starting point where you start, and also having a
oh,
number of
yeah.
yeah. So you can
From my experience, like what I experienced is like if I study from the PDF, I will not be able to remind it that much easily. But if I study from the book, then
yeah,
I will be easily able to remind that. Like I can remember it longer if I study
exactly.
from the book. I have means in exam I experienced that.
Yeah,
I can
book
note
is
two
very.
problems from the book and one problem from the PDF. You can say.
Yeah, it's always happened that physical connection, physical book is really impactful. That's how we studied our education, right? So at least having one book
Yeah,
is
yeah.
encouraged, I would say. You can definitely find these problems online. So I would so here is a string permutation. I'm just explaining the algorithms, and then we can wind off for today. One is check if a string has all unique characters. It's a very simple ASCII character problem. So I will give you a string, and if every character is unique, you return true. If there is any duplicate, simply return false. Okay. And the next one is permutations. Check permutation. Given two strings, write a method to decide if one is a permutation of other. Do you guys know what is permutation? Basically, two strings are there. If one,
Repetition.
yeah, if you one string, you can transform into second string. Basically the same characters in a different order. That's the permutation. So if both are, if one is the permutation of other, return true, otherwise return false. Okay. And the next one is max occurrences. I think even I don't have the algorithm at this point, it is in the book, I think. Given a string, find the character that occurred max number of times, maximum times. So there is a big string where, if let's say the character C appeared 10 times and A appeared 9 times, you need to return C, which is maximum number of times appeared in that string. Just a count of characters, that's it. It's not a big, super complex algorithm. Just give me which character appeared or occurred max number of times in a string. So these are the three algorithms. Simple questions on strings, very interesting for discussion as well. I'm going to put it in the chat. I already put it in the Discord. So we did not have, unfortunately we don't have time to discuss today. It's almost like 10:30 for you guys, right? So we can wind off here, but definitely we can discuss next week. Sounds good.
Yeah, fine.
Awesome.
Sure, Suresh.
Awesome. Tarun, it's already, are you sleeping already? You need to wake up at 4 a.m.
No, Suresh.
Sir, I would like to add one thing.
Sure.
Uh, Sir, permutations means combinations means selection.
Hmm.
Permutations means selection and arrangement.
Arrangement.
Factorials means just arrangement.
Very good. Very good. Very interesting.
Uh,
Factorial.
Factorial means just arrangement.
Hmm.
Combinations means selection. Permutations means selection and arrangement.
Selection and arrangement. Very good. Yeah, that's very good in differences to know. Yeah, thank you for sharing that. Yeah, cool. You can definitely get. You will be able to. You will. You guys can able to find these questions online. Until next week, if you guys time, if you get time, check the solutions. And if you're already confident about it, don't search online. Try to write on the paper itself. Okay, unless like if you want to understand, if you want to look at the examples, I would encourage you to go online and look at outputs, and then try to write the algorithm without, because it's a basic string character, string manipulation, array manipulations. I encourage you to don't look at the solution immediately. Give some time to think, and muzzle, like kind of, let's do some brain exercise. Let's do take a white paper and try to do how you solve the problem. Don't write the entire code, at least have the discussion like this, different methodologies and what are the complexities of each method, space complexity, time complexity of each
Sir,
different algorithm.
per day, how much time we need to give for coding? While you are preparing, how much time do you spend for the learning the DSA, sir?
Yeah, it's all depends. I would say at least spend at least an hour. If you're seriously working on the interview, let's say you want to attend interview in next couple of days, right? Then you have to spend more than an hour.
Okay.
More than an hour, you need to spend at least 2 hours to 3 hours. If your interview is coming up in 10-15 days, just 1 hour is not enough. But if you are just learning, uh, you can have different target rather than hourly, rather than saying these many hours a day or something. Let's say you are still practicing, you are just learning, and you are not actively attending interviews. I would say, okay, this week let me practice at least 4 algorithms or 4 problems. It's just kind of weekly target. So all 4 can be in 2 days. You can finish in 2 days, you will be in a good shape, right? Or you can also think, okay, let's practice or finish 5 algorithms this week. If it is complex, right? If in once in a while, like 5 years ago, when I was trying to understand one graph algorithm, it took me more than a week to understand the algorithm. Just understand what is the logic behind it. I went to a couple of YouTube videos and Wikipedias, and because it's so complex, those kind of algorithms. So for the initial days, it will take time. But for the simple algorithms like arrays and strings, you will be able to finish more than one, at least 3 or 4 in a week, right? So that is a different way of putting your target. Because if you say, hey, 1 hour every day, you can't make it because of all the other things happening in our lives, right? Just like I will put weekly targets rather than daily targets. Sounds good. Somebody sharing
Yes, sir.
whiteboard. Is it a whiteboard in the Jitsi? Looks like a whiteboard, right? Your browser's zoom level is not at to
Yeah,
100%.
yes, yes.
Very interesting. Very interesting. I never used this feature. So let me put 100%. Then will I be able to write it? I don't know who started this. Oh, nice. So we can write it
Oh,
here.
I only by mistake.
No problem. No problem. That's good. But anyway, so those are the things I would say. All the best, and meet you next week then. Okay.
Thank you, Suresh. Thank
Okay,
you,
sir.
guys.
Thank you, sir.
Bye.
Thank you, sir.
It was
Awesome.
nice meeting you,
You.
and thank you for the session. And
Good night,